Hello, all. Today, we are going to talk about contract driven development. The ideas shared in this video would help you bring operational efficiency for systems developed in parallel. Let's start by looking into the agenda. We'll start by looking into the theory of what, why, and how of CDD. We will then look into what is a contract, followed by the common problem areas in this approach and some best practice idea, followed by introducing a tool called Mockup and a small demo to give a flavor of how CDD would actually happen in real time. Going to market early is very important to have a competitive advantage for a product. Sometimes, for an organization, it is seen that the backend services and the front end, which could be mobile, is developed in parallel. Therefore, mobile app may not have the services to consume to develop a feature. So what can be done in this case? That's the problem statement that we'll try to solve by understanding contract driven development. Now that we know the problem statement, let's try to understand what is contract driven development. It is a strategy where different teams come together and agree on a contract. The teams are creating system that would be interacting each other. The contract thus serves as the definition of communication between the two systems. This strategy enables team to be independent of each other, and at the time of integration, the contract would be the source of truth, which can be changed with a minimal effort so that system integrates and functions seamlessly together. Let me highlight a point by taking an example. In case of a backend communicating with mobile application, the contract would be the response and the request structure, whereas the configuration would be the URL pointing to the backend system. Thus, the contract driven development in a nutshell would be agreeing on a contract that would have the least possibility of change and mocking the integrating system with the contract to continue on the development independently until integration. Let's look at a real life example. The example shows a login request, login response, which is success and failure. It also depicts the endpoint URL. The backend team and the mobile team, which is consuming the login, would come together and agree on this contract. So what it says is that for a request, there will be two params, username and password in the JSON structure. And in response, it will have status, message, and token. The token would be JWT. The response failure would have status as well as message. This is the contract that is agreed upon. The optionality of different parameters also would be discussed here. For example, in case of login response failure, a message would be optional. That's a contract that would be decided and agreed upon by the two parties. The endpoint URL for production for the other environments such as QA would also be shared. And if you look at v1 slash account slash login would be the path for hitting the login service. Thus, at the end of this discussion, the two teams will have clear idea as to what is that the consuming team would get and what is that the providing team should expose. The example that we talked is a typical pattern that we'll see in all the contract conversation. Now let's look into the common problem area that would happen in this setup. First, it will be the last minute changes in contract which are not communicated. It can cause serious breakage for the consuming application. inability to fulfill the contract due to the backend system challenges. For example, the downstream system that the backend is connecting to doesn't have the data to fulfill the contract. This would mean that there is no way in which backend can fulfill the contract. Therefore, the team should discuss and find the alternative in this scenario. The next one is leakage or missing of business scenario. The development stage happens much after the contract is discussed. There could be possible or potential information gap on the feature that has been developed. This would ideally mean that the contract is not having the entirety or the coverage of entirety of the business scenario, which could be found later in the stage. The earlier the team finds it, the conversation should happen to reevaluate the contract. The last one is developer oversight. This can happen at both the side, the consuming as well as the side which is providing. Now, in the consuming side, let's talk from a mobile point of view. We'll be somehow mocking to connect to the backend system. Now, in real life, the edge case scenarios like error, network delay, service unavailable, or authorization to connect with a particular service are some of the scenario that one may miss in development. So special care and thought process should be put in to understand that these are some of the scenario that we have to handle. The intent to highlight here is that as a team, one should be very careful about what are the different scenarios and edge cases and should somehow have a common mechanism to handle these. Being said that, there are always means to mitigate these problems. Let's look into some of the best practices or cadence that the team could follow. Close collaboration between the team is very critical. By agreeing on a contract, the key is to ensure reducing any delays in communication for the change of contract requirement. This would reduce unnecessary rework. The other aspect is that there would be potentially optional and non-optional data. Understanding this would be key in preventing any breakages while consuming it. The last one is having a backward compatibility. Let's say two teams agreed on a contract, but the, the team that is providing figured out that there is a potential another consumer which needs additional data, or due to some reason, let's say one parameter that they agree is not available. Now, in either of these cases, maintaining the existing contract and adding on top of it rather than deleting anything would be a better strategy. This might feel redundant, but the point is that at least for some point of time, let's say if it is during the release time, this should give a leverage of time to the consumer to refactor it later. We are pretty much done with the theoretical side of the contract driven development. Let's look at a tool called Mockup that would help mobile development team to mock. The Mockup tool is an open source version and can be downloaded from the website. Let's open that. We are showing the steps to download and clicking the appropriate version, the package would be downloaded. It is already pre-installed in this machine, therefore we'll directly open it. Clicking the icon will open it and the application. In the application, there are two options. One is importing an existing configuration or creating a new local environment. Environment is the collection of the different mock services. We are creating a simple Mokun demo and saving it in appropriate folder of the choice. In this case, it's a Mockup folder, and you can start adding configuration. So there are different options. We'll create an HTTP route. We have options to select what is the kind of HTTP method, and after that, we'll give the path, the appropriate response that is required can be configured. We'll create a test get method. In that, we are giving a JSON with one value. The data is now configured. Similarly, we can add multiple response. Here we are going to show a 404. 404 doesn't require. So we have configured two different response. Now let's go try out localhost 3004 test get. Yeah, site cannot be reached. So we have not started the server. So the green icon starts a server and the 3000 port is configured as well. We can configure it into a different one, but I'm keeping that as a default. Once it is started, we'll get the response. So this behaves as a get service, and this can be achieved without much effort. I have modified now. This is just to make it clear that it can be modified without restarting the server. We have sent only 200 response. If you look at the flag there, that selects the default response. If you change or select the 404, from now on, when you hit the service, we'll be getting 404. So yeah, there was some response for 404. Now we are deleting that. We are going to change that also to, let's say, we'll select not found, or say not found it is. Okay. Now let's go hit. See, we have modified the multiple the second response and we are getting 404. We can inspect the request response using the browser tool, and from that we'll be able to validate what has been the request and response. Feel free to explore after this with the tools to understand more. We'll add a body to this response of 404 and we'll try to hit again. Now in the Chrome tool, for the latest response, we'll be able to see the body. So we can configure this the way we want. But the point is, this is how you can mock a backend service without much effort and continue the development. Even the delay, all those things can be configured. Let's add a new endpoint as well. This is a post, and we'll add a version 1 slash account slash login as path. And in the response, we will give three params: status, message, and token. Token is a JWT. Once this is configured, you can, add the error also. Error potentially could be not wrong, the same. Once pretty much this is done, we can restart the server. Now the two services are ready to be consumed with the local host colon 3000 by any mobile application or any other application. We'll be focusing on mobile application in this case. Now let's look at the consumer side code demo. We've already written the boilerplate that is required to consume. We have three environments, and The mock environment is configured with localhost colon 3000, which is pointing to the Mockun. And let's have the data. Let data for the service v1 slash account slash login. We have configured the appropriate codable object and we have added the relative paths. So we have added other relative paths as well, which can be developed in future. And the endpoint. Endpoint is the URL session abstraction to call the post method. It passes the parameter as body and expects a result and prints the result. That's what we are doing right now. And a button click is called that invokes the endpoint. The environment object is passed via the at environment property wrapper, and in the application it is configured during the start of the application in the content. So base URL is what you see here, which is showcased already, and let's run the application. On clicking the sample request, you can see the print. It is having the localhost base URL v1 slash account slash login, and we are getting an error. Okay, could not connect to the server. Okay, we have not started. Yeah, let's start it again. Once you started, yeah, clearing the logs. Let's click again. Okay, there is another error, parse error. So we are able to hit, but there is some error in the way in which we are parsing. Okay, let's look at the response. Token message, everything seems fine. Okay, in the data, there is a mistake. Okay, yeah, the comma is missing in the success or status. We'll add that. That's it. Now let's hit it again. Cool. We are able to get the response. Fantastic. Let's try the 404 version. We change the default behavior. We are going to clear the logs and hit the service again. We are getting the 404. So that simple it is. In actuality, what happens is that now if we go back to the sample app, just changing the parameter to QA would do the trick. It will point the environment to the actual. Once we rerun and once we hit, if you see, the URL points to qa.example.com and the rest all the path remains the same. This was configured in the environment class. Thus ends the example demo for showcasing the contract-driven development. In conclusion, hope watching till now helped you understand the essentials of contract-driven development, and wanted to highlight that Mockup is one of the many tools out there. Feel free to explore and evaluate the features and the requirement that you have as per the context that you are operating with.